We need to talk first about the difference between a combination and a permutation. How do you distinguish between the two? In a combination, the order doesn't matter. So in a combination, 12 and 21 are exactly the same thing. Examples of combinations would be handshakes, groups. If I said you two are in a group, you two are in a group, you two are in a group, then there's no partner 1 or partner 2. So if it's a group without any order, it's a combination. And we calculate combinations using the NCR button on our calculator. So in a permutation, the order does matter, like phone numbers, license plates. If I said your partner A and your partner B, that would be a permutation. Permutations can be split in 2 groups. Without replacement. What does without replacement mean? Imagine drawing marbles from a bag with numbers on them. You pull out a marble, it's a 6, you write it down, you throw the marble back in the bag. That would be considered replacement. So without replacement, if you never put the marbles back in the bag, you're not allowed to reuse digits. So without replacement, 11 does not exist. And that's calculated either using the NPR button, or you can write out the number of possibilities and just fill in the numbers and multiply them together. With replacement means you can put the marbles back in the bag, and every time you put them back in, there's the chance of drawing that same marble again. So if we have with replacement, then 11 exists. And there's no special button on your calculator. You just write out the number of digits and then fill in the numbers, or you can use the formula n to the r. So the hardest thing you're going to do is figuring out what type each problem is, and once you figure that out, the calculations are simple. So first problem, the total number of possible zip codes, if you're allowed to include zeros. Would that be a combination or a permutation? Would be a combination. Nobody's disagreeing with me. It's not a combination. It's a permutation. Is the zip code 123 different than the zip code 321? Yes, so order matters. So this is a permutation with or without replacement. With, because is 11111 a zip code? Yeah, it could be. So this is a permutation with replacement, so all we do is line up the number of digits and then figure out how many possibilities there are for each spot. So for digit 1, how many numbers are there? Only 5 numbers you could put in there? 10. All the numbers 0 through 9. So there are 10 options for the first digit. What about the second digit? 10, because we're allowed to reuse. So 10, 10, and 10, which is 10 to the 5th, which is 100,000. Now, we should have known that, right? What is the lowest possible zip code? All zeros. What's the highest possible zip code? All 9s. Well, how many numbers are there from here to here? Well, 99,999 plus 1, which is 100,000. Okay, second one. If there are 10 different fruits at the store, how many fruit salads can be made using 3 fruit? And we're assuming you use them in equal quantities and you can't do 2 parts of one and 1 part of another. Is this a combination or a permutation? Does order matter? Is an apple, banana, cherry salad different than a cherry, apple, banana salad? No, they're the same, which means it's a combination. So we use NCR. What is our N? 10, and our R? 3. So calculate 10C3. 120. So there are 120 ways to make a fruit salad using 3 fruits if there are 10 fruits to choose from. Now, we learned yesterday that 10C3 is actually equivalent to 10C. If you have 10 fruit to choose from, choosing 3 is exactly the same as choosing. No. If I choose 3, I leave out 7. Right? So choosing 3 is the same as choosing 7. Because the number you choose is equivalent to the number you don't choose. So if you do choose 3, then you didn't choose 7, which is the same thing as choosing 3 and not choosing, or sorry, choosing 7 and not choosing 3. Okay. Last one. How many different ways can you watch 6 episodes of Supernatural? And we're going to assume that you watch each episode once, and you watch them in any random order you want. Combination or permutation? Combination? So it doesn't matter what order you watch them in? Well, so if it's a combination, how many ways are there to watch 6 movies? Just one. If the order doesn't matter, there's only one way to do it. You watch all of them. So this, if you did 6C6, you have 6 to choose from, and you watch all 6 of them, that's going to be 1. It's like saying if you have 6 books, how many ways are there to bring all of them to school? Just one. You bring them all. So it doesn't make any sense for this to be a combination, because you could watch them in different orders. You could watch the 3rd episode, then the 5th episode, then the 2nd, or whatever. So it's a permutation with or without replacement. Without. How come? You're probably not going to watch episode 3 more than once, unless it's a really good episode, I guess. So this one we can calculate using NPR. What is my N? 6 episodes to choose from. How many episodes am I going to watch? All 6. So what is 6P6? 720. And we learned yesterday that with permutations, choosing all 6 is exactly the same as choosing 5. How come? If you plan on watching all 6 episodes, there are 720 ways you could watch those. If I plan on only watching 5 of the episodes, there are still 720 ways. Do you remember why that's the case? Why the last one and the second to last one are always the same? What's that? Once you pick the second to last episode, the last episode is chosen for you. So if I line this out using the row calculation, how many options are there for the first episode to watch? 6. How many are there for the second episode? 5. And then I have 4 choices and 3 choices. But what happens when I make the second to last choice? The last one is automatically decided. Whether or not I watch it, it's already decided. So I could put 2 times 1, but even if that 1's not there, the answer is still 720. Because as soon as you pick the second to last episode, you have picked the last episode. And that's with the permutation without replacement. All right, did we have any questions on last night's homework? There is one problem I want to review. So there was a problem that says there are 15 people on a baseball team. If 9 people get to play, how many ways are there for that to happen? Is that a combination or a permutation? So I have 15 players, and I say, you, and you get to play today. Is that a combination or a permutation? Combination because there's no order. It's just a group of people. This is going to be a combination because I'm just picking a group of 9 people. I didn't tell them where to play. I didn't tell them how to bat. I just said, you 9 get to play. So this would be 15C9 to calculate the number of ways to let people play baseball. The next problem said, how many different batting orders are there? Would that be a combination or a permutation? That's a permutation because if I bat first, that's different from me batting second. So 12 and 21 would be 2 different batting orders. Would it be with replacement or without replacement? A batting order, would that be with or without replacement? Why without? Right, you can't bat twice. I mean, you can't occupy 2 spaces in the batting order. What's your Cody? Cody could probably do it. All right. So today we're going to do probability using combinations and permutations. So if you look at the second paragraph on this worksheet, probabilities can be expressed using a fraction, percentage, or decimal. For example, suppose that a particular event is expected to occur once in every 8 tries. The probability could be either 0.125, 12.5%, or 1/8. Those all mean the exact same thing. To find a particular probability, you take the number of ways an event can occur and divide it by the total number of events. So you're going to take the part and divide it by the whole. So for each of these problems, the whole is going to be the same, and then the part will change. Let's start with something simple. There are 2 red, 3 white, and 5 green golf balls in a bag. Determine the probability of each event below. If one ball is selected out of the bag, what is the probability of drawing a red golf ball? Well, I have 2 red golf balls in the bag, and there are a total of 10 golf balls in the bag, so the whole would be 10, and the part would be 2. So the probability is 2 out of 10, but we always simplify probabilities, and it's going to be 1/5. And it asks you to give the fraction and the decimal. What is the decimal for 1/5? 20% or 0.2. Okay, let's go down to D. What is the probability of drawing a red or green? So there are 2 reds, 5 greens, for a total of 7 out of 10. Or the decimal would be 0.7. Everybody okay with that? Part G asks, not drawing a red. How would you not draw a red? How'd you get 8, Cody? So if you don't draw a red, then you must have drawn a green or a white. So the probability of green or white is 8 out of 10, which is 4/5, which is 0.8. Is there any other way to calculate that? Sorry, not 4/8, 4/5. How else could you get 8/10 if you don't draw a red? Well, right, what is the probability of drawing a red? 2 out of 10. So if you have a 2 out of 10 chance of drawing a red, what is the probability that you don't draw a red? The difference between 10 and 2, 8 out of 10. Okay, I'm going to give you a minute to fill in the rest of that. I'll pause the video. So do B through I. I believe those answers are in the back. Is that true? Okay, so you can check your answers on the back. Let's go down. Suppose a certain lottery involves selecting a 3-digit number, where each of the digits could be any number 1 through 5. To calculate each probability, we need to determine how many ways the given event can occur and divide it by the total number of events. So if I have a 3-digit lottery number, you just pick any 3-digit number, and then you see if the winning number is also the same thing. Then how am I going to calculate how many numbers there are? Is that a combination or a permutation? Well, is the number 123 different from the number 321? Yes. So that means it's a permutation. With replacement or without replacement? Well, let's look here where each digit could be any number 1 through 5. So could I have 222? Yes. So it's with replacement. Whenever you have permutation with replacement, you line up your digits. How many options are there for digit 1? 5. How many for digit 2? Well, it's with replacement, so I'm allowed to reuse a number, 555, which is a total of 125. So we're going to divide each of these specific events by the total number of events, 125. Letter J. What is the probability that 321 is the winning number? Well, how many ways can you pick 321? Once. So it would be 1 out of 125. Letter K. What is the probability that none of the 3 winning numbers are the same? Well, we could write them all out, right? We could do 1, 2, 3, 1, 2, 4, 1, 2, 5. That's going to take way too much time. What's that? It's more than 5. Well, let's think about it. These are permutations, right? So I should be able to calculate it by writing out the digits. How many options are there for digit 1? 5. The first number could be any number 1 through 5. What about the second digit? Not 5. Whatever this first digit is, I'm not allowed to use it again. So if this first digit was a 2, then the second one could be anything but a 2. So it would be 4. How many options for digit 3? 3, because whatever the first number is and whatever the second number is, I'm not allowed to reuse that. So this is actually just a permutation without replacement. Once you use a number, you're not allowed to duplicate it. So we could have done 5p3. In either case, 5 times 4 is 20 times 3 is 60. So the probability is 60 out of 125, which simplifies to be 12/25. So you have a 12 chance in 25 that there are no duplicate numbers in your answer. Letter L. What is the probability that the first number is a 5? No. Probability that the first number is a 5. Well, this is a permutation, so let's write it out. If the first number is a 5, how many ways are there to pick the first number? 1. It's a 5. What about the second number? Am I allowed to reuse a 5? Sure. So it could be a 1, 2, 3, 4, or 5. So there are 5 options. What about the last number? I still have 5 options. So that would be 25. Well, what is 25 over 125? 0.2, which is 1/5. Did anybody see an easier way to do that? An easier way to get 1/5? Well, I mean, without doing any of this stuff. That's it. So, sorry, I didn't hear you. So, how many numbers are there that have a 1 in the first spot? How many numbers are there that have a 1 in the first spot? We can divide this into 5 categories. The 100s, the 200s, the 3, 4, and 500s. Right? Well, there are 5 possibilities here and 5 possibilities here, so there are 25 of those. How many of these are there? The same, the same, the same, the same, and that's where our 125 comes from. So we could have said, oh, 25 over 125. But Robbie's smarter than that. And Robbie said, wait a minute. Robbie's smarter than that. So Robbie said, wait a minute. There are 5 options for the first number. How many ways are there for the first number to be a 5? Well, it's just 1 in 5. Because this first number can be 5 different numbers, and once you pick that first number, then there's the same amount of numbers after that. So Robbie just said, oh, how many ways are there to pick the first number? 5. And the other 2 numbers don't matter. So the answer is simply 1/5. Okay? All right, this next one is tough. It's probably the hardest one you're going to see today. What is the probability that the winning number contains at least 2 3s? So we have 125 choices. How many of those choices have 2 3s or more? Well, let me help you out a little bit with this. Let's assume that the first 2 numbers are 3s. So I have, how many ways are there to put a 3 in the first spot? 1. How many ways are there to put a 3 in the second spot? 1. And then how many options do I have for the last digit? 5. So this represents 330 something. Okay? And there are 5 ways to do a 330 something. So this is a total of 5 options. But is that the only way to have 2 3s? What are the other ways? What if it's in the last 2 spots? So what if I had blank 3 3? How many options are there for digit 1? 5. How many for digit 2? 1, because it has to be a 3. And digit 3 would also have to be a 1, so I have 5. Are those the only 2 ways to have 2 3s? No. So what's the other way? 3 blank 3. So if I line that up, how many ways are there for digit 1? 1, and digit 2, 5, and digit 3 is 1. That gives me a total of 5 for a total of 15. But we messed up. Our number is too big. We overlooked something. It's kind of hard to see. You can use 3 threes. And that's kind of our problem. Does anybody see it? Which 5? So this is totally correct. But the other 2 rows are wrong. The number we calculated is too big. Why would it be 4? What's that? 333 is already taken. So let me write it out. Let me write out this list. 331, 332, 333, 334, and 335. We're totally correct there. But what happens when we try to make the second list? What would the second list look like? 133, 233, 333, 433, and 533. What's wrong with that? I've already used this one. So just because I wrote it down twice, does that mean it exists twice? No. So this number is wrong. It should be a 4 because I've already used 333 in the top version. What about the last row? Would it be 3? Well, let's write it out. 313, 323, 333, 343, and 353. How many of those do I need to get rid of? Just one of them. So this number should be a 4. So there are 2 ways to do this. Either you calculate your 15 possibilities and you realize that 333 has happened 3 times. Each row counted 333. So I have 3 versions and I need to get rid of 2 versions. So I would do 15 minus 2 would be 13. The other way would be Robbie's way, and you say, okay, this row contains 333, so the other 2 rows are not allowed to contain 333. So you change the 5s to 4s, and either way, if you do 15 minus 2 or 5 plus 4 plus 4, you get 13 out of 125 total possibilities. So if you end up with more than one row calculation, there's a very good chance you duplicate numbers. So anytime you have multiple rows, make sure that you don't count a number more than once. Or sometimes you don't count numbers that you should count. So you have to be careful. Letter N. What is the probability that all of the numbers are the same? There's only one way to do it. 5 ways. How come? We have a 1, so all 1s, all 2s, all 3s, all 4s, and all 5s, which would be 5 out of 125, which is going to be 1 out of 25. And the last one on this page, letter O. What is the probability that all of the numbers are less than 5? Yeah, I know. Less that 5. How are we going to figure that out? Well, it's a permutation, so we can line it up. How many options are there for the first letter, first number? Not 5, 4, because 5s aren't allowed. So 4 choices there. Am I allowed to duplicate? Yes. So 4 and 4 again, which is a total of 64. Divide that by 125, and that would be your probability. So the hardest thing you're going to do in this chapter is just decide, is it a combination or is it a permutation? If you decide that it's a permutation, you need to know, is there replacement or not? And if you don't understand that, I recommend you go on tonight and re-watch yesterday's video so that you can really cement that combination and permutations. If you have questions about the video, you can ask me. You could also re-watch this video. It would also help. So last night's video is already posted. Okay. Next page. Sometimes it's a lot easier to write out the possibilities than it is to think about combinations and permutations. So we're going to look at a coin flipping scenario. And coin flips are really confusing. It's hard to decide if it's a combination or a permutation. So at the top of this page, if 2 coins are flipped, what is the probability of getting at least 1 head? Well, let's decide first. Is this a combination or is it a permutation? I have 1 vote for permutation. Combination? It's kind of hard to decide. We had an argument last period for about 5 minutes on what it was. I'm not quite sure I convinced her. Yes. So, let's write out the possibilities and then we'll decide if it's a combination or a permutation. If I flip 2 coins, what are the possible outcomes? Heads, heads, tails, tails, head, tails, and now we need to decide, is heads, tails different than tails, heads? This is the big debate. Oh, that's a good way to look at it. Can you have doubles in a combination? No. So if you looked at it that way, then it simply can't be a combination, because combinations are not allowed to have doubles. So that's one way to look at it. I never thought of it that way. But remember, either you're flipping 2 different coins, in which case we could call them coin A and coin B. So if I'm flipping a coin A and a coin B, would that be a combination or a permutation? Would have to be a permutation, because it's 2 different coins, and a head on A is different than a head on B. Okay? The other way to look at it is you flip the same coin twice. So your first flip could be heads, and your second flip could be tails. In which case, is tails head the same or different? Different, because we did flip 1 first and 1 second. And either way you look at it, it's going to be a permutation. And the fact that it has heads, heads means it's a permutation with replacement. So we count both HT and TH. Okay. So, number 1, what is the probability of getting at least 1 head? Well, how many of them have H's in there? All but 1. So the answer would be 75% or 3/4. Now the key word there is at least. Does HH count as at least 1? Yes, it does. Okay. The next one down, if 2 coins are flipped, and you know that one of the coins is a tail, how does that change the story? So it's one of those, and the HH disappears. So if you know that the HH is gone, what is the probability of getting at least one head? 2/3, 2 out of 3. Okay, you have about probably 4 minutes to work on this. This worksheet is going to be due tomorrow. So I recommend you don't waste this next 4 minutes. Some of it's confusing. That's on purpose. If you look at 10 through 12, there are 6 names. Kathy, Abigail, Mary, and Winifred are all girls. Bill and James would be boys. If you didn't know. A lot of people have questions on Winifred. Okay, this is due tomorrow.